Our lesson today on section 6.2 is on something called volumetric analysis. This is going to take the concept we did before with molarity and combine that with stoichiometry, which at this point we should be pretty familiar with. So that's what our section today is going to be on. The problems are going to look kind of similar, but instead of dealing with grams and molar mass, right, this is what we were dealing with before, grams and molar mass. We're going to be dealing with molarity, right, moles, and volume. Okay, so we're just using different variables and solving stoichiometry problems. So what this is a definition: volumetric analysis, determining limiting reactants and amount of products using molarity, okay, instead of grams and molar mass. So we're talking about solutions and concentrations. We're going to use this frequently with acids and bases, which is coming up here very, very shortly. We have to know about whether we have neutralized something or not, and how much we need to add based on how concentrated an acid is. So we need to know this pretty well in order for us to deal with acids and bases safely. Problem-solving strategy is pretty much the same as a limiting reactant problem that we were doing before, but instead we're dealing with molarities and volumes instead of grams and molar mass. Okay, so problems are going to look just like this, right? These are pretty much what they've looked like so far when we were doing stoichiometry problems. You get an equation. First thing you do is you have to make sure you balance it. B is a little bit different because it's not talking about grams, it's talking about volumes and concentrations. Okay, so we'll see what this looks like and how we solve that in a moment. C, what's the mass of CUS produced in this reaction? That's very similar to problems we've seen before. How much product do you make, right? That's how you set up your mole ratio in your stoichiometry part of this. And D, what's the concentration of NaCl when the reaction is complete? So this is a little bit different here. We'll see how to do this because we haven't seen this sort of problem before. It's similar to how much excess reactant is left over. We're dealing with another product, and we'll talk about how we calculate this concentration. Okay, so first thing we would want to do is to balance this, and pretty much all you need to do is just put a 2 in front of the NaCl. Okay, so with that set up, what we need to do is create 2 stoichiometry setups, okay, in order to solve C about what's the mass of this. This is what we're going to choose for our mole ratio. But instead of dealing with, right, grams divided by molar mass, right, 1 over molar mass, if you wanted to think of it like that, and then going on and setting up our mole ratio like we have in the past, okay, and then multiplying times the molar mass of whatever it was that we were looking for would give us some answer, right? This is what we were doing before. We aren't going to do that. It's going to be a little bit different this time. Okay, so instead of that being the setup, there we go, come on here, it's not going to let me do it, okay. Instead of that being the setup, how we calculate moles isn't grams divided by molar mass anymore. Okay, this time, right, if we go back to my molarity equals moles over liters or moles over volume formula, getting moles by itself, okay, is just molarity times liters. So instead of starting, basically all we're doing is we're taking this part of the equation that we were doing before with stoichiometry and replacing it with this. Okay, all the rest of this business here is going to stay similar, at least if we're trying to find the mass of something, we're going to use molar mass here. But this mole ratio part of this stays the same. This part, if it asks for the mass of one of the products, that stays the same. We'll see how it's different for part D when it asks about the concentration of NaCl that's left over. But the rest of this is going to stay the same. So in order to set this up, okay, for the first one, my molarity of the CuCl2 is 0.500 molar, and the volume, now it has to be in liters here, is 0.0100 liters. Okay, and all that did is basically replace this part of my stoichiometry setup that I've done so far. Okay. Then we can use a mole ratio. We are looking for CUS. We are starting with CuCl2. It's a 1 over 1 ratio. And then finally, right, since it wants a mass, we need to multiply times the molar mass of CUS, which is see here, 95.62. So here we go. So we have 0.5 times 0.01, okay, times 1, right? And then times 95.62. The answer needs 3 significant figures. This comes out to being 0.478 grams of CUS. Okay, and in fact, a lot of you will find this easier than this setup because you have one less molar mass you have to find, and this information is given to you in the problem. So the first part of this setup is really easy. Okay, then we do it again for the second one, and then we figure out which one made the least amount, and that tells us what the limiting reactant is. So let's set up part 2 of this. We have 0.350 molar Na2S, okay, and we have 10 milliliters of that. So you can kind of already see where this is going just based on how we're starting here. Mole ratio, we're still looking for CUS. And this time we're starting with Na2S, which is still a 1/1 ratio, and then multiplying times the molar mass of CUS would get us into the mass of CUS. And you can already tell based on how this is going to start that this is less than the previous one. So 0.350 times 0.01, right, times 1 times 95.62. Okay, and this is 0.335 grams of CUS. So what's the limiting reactant here? The limiting reactant is Na2S, right? The stuff that started over here because that made less product. And this number over here is going to be your answer in C. Okay, 0.335 grams of CUS. All right, so we don't need to redo the work. Oops. All we got to do is just 0.335 grams of CUS is the answer there. That's how much gets made in grams. Okay, and then we're going to do part D, which is something we haven't quite seen yet. So D says, what is the concentration of NaCl when the reaction is complete? So what we're going to do here, we're asking about the other product, and since it is aqueous, okay, it's dissolved in solution, so you can't really find a mass of it because it's dissolved in water. What we do want to find, though, is the concentration of it. So how we are going to do that, okay, we're going to take our limiting reactant, which was the Na2S, right, and our information about the Na2S, and turn it into NaCl. So we've got here it was 0.350 molar, and we had 10 milliliters of it, so 0.0100 liters, okay, and you just go straight into the mole ratio after that. This time we're turning it into, let's not forget there's a 2 there, okay, turning it into NaCl, and we started with Na2S, so that is a 2/1 ratio, and I don't need to put it into grams here because all I'm worried about is the concentration of NaCl, right? And concentration is moles over liters. So if I stop here, I end in moles. I don't need to turn it into grams because my setup for this part only requires moles. So I don't need to do this last step, actually. All I got to do is this. So you have, 0.350 times 0.01 times 2. Okay, and we get this rather small number, 0.007, and we're going to give it 3 sig figs, 0.00700 moles of NaCl. Okay, so that is the top half, right, this part here, okay, of my molarity equation. The bottom half, so where do we get the volume? Well, what did we do? We added 2 solutions together, right? So if you want to think about it, we have a beaker here. We poured in the first one into the beaker, right? Solution number 1. And then we poured in solution number 2 into the beaker, right? So we had 2 volumes that added together, right? The first one was 10.0 milliliters. The second one was 10.0 milliliters. So my volume part of this isn't 10, but it's actually both of them added together, which is 20. So whenever we do this, what's the concentration of one of the products? You got to remember the volumes are additive here. We put them together. So setting this up, my number of moles was 0.00700 moles, and my volume, which has got to be in liters again, right, is 20.0 milliliters, but that's 0.0200 liters, so that's going to be on the bottom. Okay, and my concentration of NaCl at the end of this whole thing is 0.00700 divided by 0.02. Okay, and this is 0.350 molar. So that's the concentration of NaCl. Okay, that's all there is to this. Basically, we're just mixing stoichiometry with what we already know about molarity.